All right, Andrea Jones, let's talk about Venus. I feel like Mars gets all the attention, so I'm very excited to hear all about Venus. First, can you start by giving me a little bit of background on the planet itself?
Sure. So Venus is sometimes called our planetary twin, but I like to think of Venus as Earth's evil twin. So Earth and Venus are similar in size. They're both rocky planets, but Venus has this really thick, toxic atmosphere that's full of sulfuric acid clouds. It has temperatures so hot, they're like the inside of a pizza oven. And the pressure at the surface is sort of like being at the bottom of the ocean. It's really an amazingly harsh environment now, but we think at one time Venus may have been more like Earth and possibly even had oceans on it. So how the planets are similar and different is really a neat thing to study.
Wow, I didn't know that about the history. I bet that helps learn something about our planet then, if we're looking at the history of Venus.
Absolutely, yeah. So we think that Venus and Earth started on a pretty similar trajectory. So we both formed in the same solar system. We're planetary siblings, but yet where Earth is now and where Venus is now are very, very different places. And trying to understand how that happened, why is that, and what implications does that have for us here on Earth? These are really big questions that we're trying to investigate with our DAVINCI mission.
Yeah, so tell me about the mission. What's the timeline on this, and what's the plan here? What's the ultimate goal?
So Da Vinci is one of the two missions NASA selected to go to Venus, and we will be launching in June of 2029. We're going to head to Venus, and then in June of 2031, we are going to drop a probe into Venus's atmosphere. So this probe kind of looks like a deep sea vessel more than a spacecraft, and it's about the diameter of a hula hoop, so about a beach ball about the size of a hula hoop, made of titanium, and it's going to go down through the atmosphere, taking measurements of the atmospheric chemistry, of the composition, the pressure, what's going on in each layer of the atmosphere as it heads towards the surface. That will take about 1 hour. And then after we get below the cloud decks, we're going to take the first images of the ancient highlands of Venus from beneath the clouds. So this mission will help us better understand water on the planet. It will help us understand how the atmosphere interacts with the surface. And again, those really incredible images, like you and I were there to see these really neat highlands.
So if Venus is so inhospitable, what is this probe made of that it's going to survive this journey?
Right. So it's made of titanium, and actually our little window on the bottom that where our camera will be imaging is made of sapphire. So it's really tough stuff because it's impossible to cool electronics at the temperatures that we'll experience on Venus. So what we're doing instead is we're insulating our really sensitive scientific instruments, and we're protecting them from that environment. And we can do that safely all the way down to the surface. Once we land there, we're probably not going to last a whole lot longer, but that's okay. It's really going to be all the science that we want is going to happen on the way down, and any extra time is bonus.
So what do you think that you'll find once we reach the surface? What does it look like on Venus?
Wow, well, isn't that going to be fun to find out? So, I mean, we think that where we're going is a really rocky mountainous area, and we think it might have been an ancient continent on Venus. So back in the days, if there was a big ocean, then of course there are also potential for continents. I guess there are ocean worlds that don't have continents, but we think Venus did, and we think this is a remnant of one of those ancient continents. So I think it might look like, you know, you're hiking through the desert, and you can imagine like what it would be like if you could deep sea dive and crawl up the ocean floor. It's really like an ocean of air that we're going to be going through. Getting all the way down to the surface is sort of like dropping a rock to the bottom of the ocean. By the time we get there, we're going to hit so slowly because the atmosphere is almost more like a liquid than a gas close to the surface. So I think the most fun is that we don't know exactly what we'll find, but we'll get a lot of information that can help us better understand like what is happening on Venus right now and what happened in the past.
I heard there's volcanoes potentially.
Absolutely, there are volcanoes. Whether or not they're still active is something we're still trying to investigate. And certainly, Da Vinci and Venus and Veritas will help us better understand, what is actually going on right now.
So we're talking several years away. What's happening right now with this mission? What kind of work is being done right now?
Oh, this is a really fun part of the mission. It's where we are getting through lots of different reviews. Of course, that's maybe not the most fun part, but it's we've already had the biggest brainstorming sessions where we're like, what do we want to do? What are the biggest questions? What kind of instruments could help us get answers to those questions or get us closer to answer those questions? And now we're fitting it all together. We're building the instrumentation, we're doing the testing, we're figuring out how are we going to get all of this data back to our relay satellite and back to Earth, before we smash into the ground of Venus. So it's really fun to be thinking of what are we going to do? How are we going to do it on the very fine scale? We already have all the big picture items set, but now it's in detail world. And I get to do public engagement for this mission. So I get to plan who are we going to be working with? How are we going to be working with them? How do we get the world involved in this mission and excited and understand these big mysteries that we're trying to investigate?
So you said testing. How do you test your sapphire titanium probe? Do you have like a special box of Venus atmosphere laying around somewhere? Do you send it to the bottom of the ocean? How do you do that?
Well, we test in a lot of different ways. One place that we're testing is we actually do have an environment at NASA Goddard that is a Venus chamber. So it simulates the really corrosive and hot environment of Venus, and we stick things in it and find out what happens to them and how do we make them survive. We also have places that we can go that simulate those crushing pressures, and we stick our instrumentation, we stick our probe components in there, and we see what happens. And we make sure that they're all working. We test and test and test and test and test endlessly. It's really a very important part of the engineering design process, and we are very serious about that. We want
Yeah.
things to be built and to last.
I was going to say, you guys are NASA. Of course, you have a Venus atmosphere box you can throw stuff in.
I know, it's just
What a
down the
silly
hall. It's so
question.
cool.
Okay, so I have to ask, we're a weather show. Venus has an atmosphere. Does Venus have weather?
Absolutely. So it's got clouds, it's got winds, it's got different layers of the atmosphere. So it's, of course, really cool where it intersects with space. And then it's, 900 degrees Fahrenheit or so at the surface. So we've got a lot of temperature difference in, a pretty thick amount of clouds. I mean, it's about 90 times the thickness of Earth's atmosphere. But yes, we do have sulfuric acid clouds. We have winds that move those clouds around. And so actually one of our project scientists, she started out by studying extreme weather on Earth. And now she's getting ready to study, in great detail, extreme weather on Venus. And I think that is a whole different level of extreme that we're really excited to get into.
Yeah, I recently did an interview about the weather on Mars, and it seems pretty tame compared to the weather on Venus. Like you can't complain about a bad day on Earth when you're talking about Venus weather, I guess, right?
Absolutely. It really puts things in perspective.
It does. All right, so there's a huge concentration of greenhouse gases, right, in Venus's atmosphere. So what are you going to be looking at kind of when you get this data, and how can it help us learn more about what may be in the future for Earth, not just like the next decade or 2 decades, but like thousands and millions of years down the road?
Right. So one of our project scientists was talking about how Venus could be a great example of, just the delicacy and the fragility of a habitable environment on a planet. So Venus has a lot of carbon dioxide. It's a very carbon dioxide rich atmosphere, which is a greenhouse gas, and it has the sulfuric acid clouds, which also trap the sun's heat. And this does make Venus the hottest planet in the solar system, even though it's further away from the sun than Mercury is. And we don't know exactly how this environment came to be. So we know that there were we believe that there were active volcanoes and have a great amount of evidence to suggest that there were active volcanoes, much more active than they are today if they are still active. And that would have contributed a lot of these gases to the atmosphere. What turned it from, a greenhouse effect like we experience on Earth to a runaway greenhouse effect on Venus is still something we don't fully understand. And so we are going to be like analyzing in great detail the different gases and the isotopes of the gases, and what we're finding in the different layers. Where is the oxygen? How is that interacting with the other components? And then trying to piece all of that together to see how this is similar to what we have on Earth, and how it is different, and how it is changing, and what we are looking for. Chemical fossils in the atmosphere is another way of looking at it, and trying to figure out what's the evidence of what was once there in the past, and how are the imprints of what's happening on the surface still readable in the atmosphere. That's where we're going to get a lot of this information.
Do you think that this mission will kick off exploration on other planets?
Well, I like a good investigation of any planet, but what I think is really exciting about Venus is we're studying it at a time when we're getting a lot of information about planets around other stars, and we think that Venus may be a type of planet that is common in the universe, like within our Milky Way galaxy. So with the James Webb Space Telescope, if we were observing, our star and this rocky, hot planet with this massive atmosphere, we could see it. And we actually, with James Webb, we can detect the chemistry of atmospheres of planets around other stars, which is mind-boggling. It's just unbelievable. And with this information, we can then make some inferences about what is happening on that other planet, on that exoplanet. So by studying Venus and learning more about our planetary neighbor, it can not only help us better understand our planet and our solar system and what's happened here over time, but it potentially could help us better understand solar systems throughout the Milky Way and beyond, which is so exciting.
Wow, it feels like there's been so much progress in the last 5 years when it comes to space exploration. Is that true? I mean, I remember it was 6 years ago. I was at NASA Goddard, and the Webb was being built. I saw the pieces of Webb there, and now it's just bringing these pictures from so far away. It's amazing. Has there been a lot of progress just in the past 5 to 10 years?
There has been. So, I mean, I think this is a really wonderful time to be interested in space science. We are building incredible new instruments, both for planetary exploration and for exploring our universe. I mean, James Webb took a really long time to get together, and no doubt as to why. I mean, we did incredible origami in space, and it all worked perfectly, and we wanted to make sure it would work, and it has, and it's been incredible. And so now we're reaping the rewards of all of that investment in that big infrastructure. Astrophysics missions tend to be very big projects, because we are trying to push the boundaries of what we can find further and further and further, and that's really hard to do, and those are really difficult problems, but we're now seeing what happens when you make those kinds of investments. And what's exciting for me as a planetary scientist, this is an astrophysics mission, but we're also exploring our solar system with the James Webb Space Telescope. And there are many other telescopes that are, searching for exoplanets. We have the TESS mission that's looking for exoplanets in a slightly different way, and our exploration of the solar system, we have so many missions right now that are giving us lots of different information. And for me, I really like the parts that we're finding that are similar. Where are the places where all these different worlds and these different places have things in common? And the differences are really fun too, but trying to figure out what connects us all, and the paths that we're similar, and generalizations that we can make about the entire universe that we've been able to study. I think that's really exciting.
It is really exciting. And it seems like the public eats it up. No matter what someone does, they love hearing about space. I mean, do you have any idea why that is? Why everybody, it's a common factor that everybody wants to hear about space and what's happening.
I mean, I think it might just be rooted within all of us. I mean, from the earliest days, we grew up under a fizzing sky, and I think being able to reconnect with that sky, if people are lucky enough to get out and see really, really dark skies, and those stars and the galaxies that we're able to see. There's something inside us that is like, wow, I am part of this. Like, we are all part of this universe. And I think for me, it's really nice to feel a little bit of that insignificance. Like, I feel like I have big problems sometimes. There's a rough day sometimes. And, looking out and laying down and seeing what is overhead and knowing that you're on this tiny speck of dust orbiting this slightly hotter speck of dust, within this, bunch of little tiny dots in this grander universe. To me, I find that really inspiring and empowering. And it makes me want to, make the most of my precious time and space here. But I don't know, I think the answer might be a little bit different for lots of people, but it goes back to our explorer roots and has helped us expand across the earth and expand, climb mountains, go to the bottom of the ocean, like this entrepreneur and exploration spirit we all have as a species. I think that also will always keep us reaching farther out into space.
Cool. I agree. It's good for everybody's ego to see where we stand in the world. Awesome. Andrea, can you give me a brief little background on you and like what your degrees are in and what you're doing now?
Sure. So right now I'm the public engagement lead of the Solar System Exploration Division at NASA's Goddard Space Flight Center. And related to this conversation, I'm the public engagement lead of the DAVINCI Mission. So it's really fun to be able to work with all of our planetary science missions and our research teams and find out what is happening with them. And then my job is to share it with people around the world, around the country, and help people understand what we're doing and why we're doing it and why that matters to people like you. And then, my background, I grew up, hiking and camping and outside all the time. And that led me into a field of geology. I actually couldn't decide between geology or astronomy, and the college I went to didn't have an astronomy degree. So I went there and found out planetary geology is a career path that you can take, and you can study the geology of other worlds, which is so cool. And
cool.
That's for me. So I went into that as an undergrad. Worked really hard, perhaps a little too hard, got a little tired, and then I decided to go do something really fun. And I worked at an outdoor science school in California for a while. And so I taught about, birds and squirrels and rocks and astronomy, and also line dancing and rock climbing and adventure course. And then I worked at Canyonlands National Park for a little while doing education programming there and in public lands in the area, and then missed science. And so I went to grad school at the University of Arizona and worked with space science again and dived back into the research and loved it, but still had the most energy from talking about it. And so my role now, I get to, work with the science, but also share it. And so it's nice to have a background that was both, science and education and interpretation, and try to blend those all together to help people understand, what we're doing and why it's awesome.
Well, you're fantastic at it. This was so fun. I mean, everybody that you guys work with over there is amazing, but thank you. You were wonderful. This was very inspiring, and I love your passion behind it too.
Oh, well, thank you. This was so fun. Thank you for your interest. I really appreciate it.
If you like this content, you'll love our podcast. Check out Off the Radar. You can find it anywhere you listen to podcasts, or click the link in the description of this video.